All right, hi everyone. Rather than giving you a video on this one, I'm actually going to make my own. There are some good videos on this topic, but the issue I found is that they leave out some of the steps that I want to throw in here. Plus, I want you to see how to do these kinds of things with the materials that we have as a class. So we're going to look at naming multivalent or polyvalent ionic compounds. So multivalent and polyvalent mean the same thing. Poly and multi both mean more than one, right? So more than one valency. So we're going to talk about what that means in a second. But if a compound is one of these two things, it is going to influence the way that you name it or the way that you give the chemical formula for it. So it's important to know about this because it will change the way you answer the question a little bit. So let's see how that works by naming the following compounds. Okay, so let's just name these as if we were doing this the way that we've been doing this all along. FeO and Fe2O3. Fe, so that's iron, and O is oxygen. So remember that's an anion, so that's going to be iron oxide. And then for this chemical, well, we have iron and we have oxygen, so that's iron oxide. You can maybe see the problem here, right? We have two different chemicals with two different formulas, but if we just name them the way that we've been doing it up to this point, then this would be iron oxide and this would be iron oxide. You'd have the same name for two different chemicals. So we need a way around this. And the way that they do this is with Roman numerals. So let's see how it works. It's actually attached to cations and anions. So let's look at oxygen on our periodic table of ions. So there it is. You'll notice that when oxygen becomes an ion, it becomes oxide. There's only one possibility. It becomes O2-. So anytime you have oxygen as a ion, it's going to be having a charge of -2. So we can fill in our anions here. So they're both going to be O2-. All right. So what about the cation? So we can get the cation by the same process that we've been working with before. And you'll see that the answer becomes different for this one and this one when we do that. So for O, if it has a charge of -2, for this iron to cancel it out, it's going to have the opposite charge. So if this one's -2, then the iron's going to have to be +2. Whoops. Okay, so there we go, iron +2. So then we get 2 crosses over, we get an Fe2 and an O2. But if we put that in lowest terms, it becomes FeO. Perfect, we're done. Fe2O3. So in this case, what we have here is we have an O2-, but we have 3 of them. So that gives you a total charge of -6, right? We have O2-, O2-, O2-. It has a charge of -6. So in order to balance that out, the iron will have to have a total charge of +6. But there are 2 of them, so each one must be +3. If you found that a little bit confusing, you can just do the backwards crossover method with this one, right? This is O3, so the 3 goes to the iron and the 2 goes to the oxygen. So that's Fe3 plus an O2-. So the difference really in these two chemicals is just the cation, the iron ion. And when we look it up on our periodic table of ions, we can see that yes, iron has a 3+ and a 2+. So that seems to be consistent with what we've been doing. So how does that fit into the name? Well, if it's Fe2+, when you have this situation, we put brackets and the Roman numeral 2, bracket again. So this becomes iron 2 oxide, and this one will be iron 3 oxide. Okay, so that's how we differentiate with multivalent ions. We just use Roman numerals in their names. Okay, let's look at another example. I've included this example because this is a hard one. This is one that typically mistakes are made on. And let's see why. Because if you're looking at this with the crossover method, what you might do, and here's the mistake that's often made, people look at this and say, okay, by crossover method, Sn would have to be 2+. Does that make sense? Let me check my periodic table of ions. Sn, yes, it has a 2+. Okay, so then this must be tin 2 oxide. So this must be tin 2 oxide. And this is wrong. So we have to see why this is wrong. So let's go back to what we were saying in the previous question. When you have oxygen, oxygen only has a charge of -2. That's it. That's what the oxygen ion is going to be, anion is going to be. So we call this O2-. So that means that what you have here on the oxygen, if you've got 2 of those, you've got O2- times 2, that gives you a total charge of -4, which means that the tin over here, to cancel that out, must have a charge of +4. So be careful with some of these. Be careful with the ones that have +2 and +4, because it's often easy to get them confused if you just look at it very quickly. So okay, so O2- times 2 will give you O2- 2 of them, so that's total charge of -4. And to balance that out, you've got tin 4+. So the name of this is actually tin 4 oxide. Okay, let's quickly move over to doing it the other way. So if I give you the name, can you give me the formula? So we've got copper 2 chloride, so we're going to write out our ions. This is pretty easy. Copper 2, Cu2+, chlorine, Cl is -1. Again, if you didn't know that, you could look them up. Cl is -1. Copper, they tell you, is +2. You don't even have to look it up. The name tells you that. Okay, and the formula is then going to be, by crossover method, the 1 from the Cl goes with the Cu, so Cu1, and the Cl gets the 2 from the copper, so CuCl2. Okay, last example, iron 3 nitride. So iron 3, so we know what that is, 3+. The anion, nitrogen. So again, you might know what that is because it's in one of the columns in the periodic table where all of them have, well, it gets a little bit complicated, but they all can have that charge. So what charge is that? Well, that's going to be -3, right? So you can see down here you start getting transition metals, but when you're in the non-metal section, they all have a possible charge of -3. So nitrogen will be -3. So if we were to use the crossover method, we would get Fe3, whoops, and 3. But we know that that's not right. These are ions, and this is a ratio, right? So a ratio of 3 to 3 is the same as 1 to 1. So this is actually just Fen. So Fen is the formula for iron 3 nitride. Okay, one last thing I want to mention here, and that is copper 2 chloride, iron 3 nitride. What about sodium 1 chloride? Can you write sodium chloride as sodium 1 chloride? No, don't do that. That's not done in science. So you might think, well, what's the harm in it? In a world of your own creation, there probably is no harm to it. It's just kind of like science grammar that we're learning here. And the science grammar says that you don't include the 1 there. So you'll never see sodium 1 chloride. Don't write that on a test. You will lose some marks for it because what that shows me is you're not recognizing that it is not multivalent, that sodium only has 1 charge. So if it only has 1 charge, you don't write the number. So don't write sodium 1 chloride. Don't write don't write calcium 2 chloride or something like that. Only use the Roman numerals for something that is multivalent. And how do you know if it's multivalent? Just check for the dotted line if you've got 2 charges for something. And these all fit within this category of the transition metals, or just beside here. All right, so that's all I've got to say for this one.